Okay, Algebra 1, we're on section 1.8, which is the last section in the textbook we're going to do for chapter 1. Woohoo! We've made it! Way to go. There is so much content in here. And even if you've done this before, it's just like, whoa. And it hits you hard and fast at the beginning of the school year. So the last part is something that you've probably seen before, and we throw it all together because it really does fit together, but it seems like a lot of disconnected things too. So we're working with ratios, proportions, and rates. So a ratio is really a comparison of two quantities. And the comparison is by division. And so what you'll see a lot of times is there'll be a ratio of 3 to 4. And they'll have the little colon in there. Or 3 to 4, and it'll actually have the word in there. You see that a lot in story problems. But what it's really saying is that the first number goes on the top of the fraction, and the second number goes on the bottom of the fraction. Now, what we really like is when we could start creating equations out of this. So when you can get two equal ratios, we get this proportion. And we solve them by what we call cross multiplying. Now, cross multiplying only works when there's an equal sign in here. So this is really critical to being able to cross multiply. Cross multiply doesn't work with division. Does not work with multiplication of fractions. It only works with proportions, and proportions are when two fractions are equal to each other. Another way of looking at it would be like this, but we don't use it that often. We're really big on the fractions because they make more sense mathematically. And so with cross multiplying, what we do is we multiply across. So B times C has to be equal to when I multiply across the other way. So each cross is on one side of an equation. So this would be A times D. So we're going to go ahead and look at some basic solving proportions. So I can, and you'll see people do a cross one way first or cross another way first, and it's really just preference. I tend to start with the one that has my variable first, and I don't know why. So here I would multiply across here because this has my variable. So 3 times m should be equal to, and then I multiply across the other direction, 9 times 5. So 9 times 5 gives me 45, and that's the number that goes right here. And now I'm just solving an equation. So if the 3 is right next to the m, it's multiplication. To undo multiplication, I divide. So m is equal to 15. So on this next one, you're going to see me start going diagonal the other way because this one has the y. So 2 times y, that should be equal to, when I multiply across the other way, negative 5 times 8. So negative 5 times 8 gives me negative 40. So this is negative 40. Then I divide by 2 on both sides, and y is negative 20. Some people have easier ways of solving this. Some people have their own little tricks and stuff like that. But I show this method to you because not all of your answers are going to turn out to be nice, pretty numbers. And when they do, the tricks don't work anymore. So I'm trying to show you a way that will work no matter what you come in contact with. This method will always work. You may end up with an answer of 13 over 9, but it'll be the correct answer, and it's solved. And your little tricks that say, oh, well, if 2 times 4 gives me 8, then negative 5 times 4 gives me negative 20. It doesn't work. It doesn't work anymore if it's a fraction. It throws things off, and it throws people for a loop. So finding a shortcut that works when it's nice and simple, like these ones, will be great if your answer is fine and simple. But how much in life is always just so super easy, handed to you on a silver platter and all that? We use these processes when they're nice and simple, so you're just used to it. So when it gets hard, you've got the process down, and it's one less hurdle you have to jump over. So let's go ahead and look at our next problems. And so this is where we're starting to get more complicated, because now we don't have just a y. We have a y minus 3. So when I'm multiplying my 2 times y, but I'm also multiplying it by that minus 3. And that would have to be equal to, when I multiply across the other direction, 6 times 7, which 6 times 7 is 42. And so now we have to remember to use that distributive property. So I'm timesing the 2 times y. I'm timesing the 2 times 3. And that has to be equal to 42. And now we're back to all those two-step equations. I add 6 to both sides. I divide by 2. And y is 24. Now you may be good enough that you can work backwards on this and use your little shortcuts and stuff like that. You may not. So again, I'm looking for consistency. I'm looking for a method that you can kind of go brain dead on or almost go on auto mode, because it's the same thing over and over and over and over again. And not like, oh, this trick works here, but it doesn't work here, and then I don't know what to do, so I'm going to give up because this is too hard. We work on it while it's super simple and easy, and you may have an even faster trick, but it makes it when it gets harder, you can do it still. One less hurdle for you. Okay, so let's look at the next one. We've got 4 times x plus 3. And you'll find me starting to shortcut this. Okay, so 4 times x is 4x. Plus 4 times 3 is 12. Okay. And that equals, now I'm going to multiply the other way. Okay, 5 times 7. 5 times 7 is 35. And you can do that. Skip a step. But still looking at, okay, I'm going to do the 4 times the x, the 4 times the 3. Always remembering that it's got to be multiplied by all the terms there. Okay, so from here we can get rid of the plus 12 by minusing 12. So 4x equals, let's see, 3, 2. We divide by 4 on both sides. And this brings me to my example of not every answer is really nice and pretty. And your shortcuts might not work. Some people can. Most people can't. So it's all about what's going to make you the most successful. Okay, we still got pages to go. Okay, so word problems for proportion. So this is where the highlighters really come into play. So the ratio of the number of bones in the human's ears, so ears to skull. Ears to skull. So that's where we're working on our proportions. Ears, skull. And I use this to help map out to make sure I'm putting my numbers in the right spot, because all the time when we work on problems like this, you're like, well, how do you know where the number goes, on top or bottom? And so if I map it out like this, it makes it easier. So if it says ears to skull, it goes ears to skull. 3, oops, sorry, that should be highlighter. 3 to 1. Oh, 11, sorry, 3 to 11. Now this is where it gets a little bit trickier. There are 22 bones in the skull. So where do I put 22? Where am I going with this? So 22 is for the skull, so I put 22 on bottom. What I want to know is how many there are in the ears, so I'm going to put X up in ears. So that way this whole row right here corresponds to ears. This row here corresponds to skull. And it makes sure that you put the numbers in the same place, in the correct place every single time. And then we're just solving. We cross multiply. 11 times x is equal to 3 times 22. I divide by 11. And x equals 6. Now this is where people get stuck. What is 6? What does it mean? Does it mean people? Does it mean hours? Does it mean miles? We're talking about a word problem in context. If I tell you the answer is 6, I'm like, huh? 6 what? Always tell them what it means. 6 what? Since 6 is in ears, this is 6 bones in the ears. And you'll find this to be the #1 skill that you need when it comes to college, is being able to take this stuff and apply it to situations and be able to really articulate, what in the world does this number mean? What's going on? Why am I doing this? Okay, so let's look at the next one. The ratio of games won to lost is 3-2. So I'm going to go ahead and set that up. Let's do a different color. So 1 on top to lost on bottom is 3-2. So 3-2. Now the team has won 18 games. So where does 18 games go? On top, because that's where the won games go. How many games did they lose? So on the losing part, I'm going to put X. And then when we solve. So I multiply across this way. 18 times 2 is 36. And that's equal to when I multiply across this way. 3 times X is 3X. Divide by 3. X is equal to 12. Now some people could probably do that in their head. Some people can't. I could probably do that in my head. I've been teaching long enough. I could probably do this in my head. But does it mean that it's okay for me to not show the work? No, that's how I show you that I know what I'm doing. That's how I show you how to get through stuff. And when you are doing work in a class, you're demonstrating the knowledge you have. And if you're not showing the work, you're not demonstrating your knowledge. That's what we assess as teachers. We assess what do you know? What skills do you have? If you can't show me, I can't assess that, and so I can't grade it, so I can't give you a grade. So even if you can do it in your head, demonstrate why this works. Or if you don't want to show your work this way, see, I'm a math person. I prefer not to write in words unless I have to. So if you want to, you can write me a paragraph that explains your thought process on how you did it in your head. Feel free. I still think it's easier to just show your work like this. And then I made a mistake. Anyone catch my mistake? I didn't say what 12 was. 12 games lost. I didn't finish that off. Bad teacher. Okay, so we're running through time so fast. We've got so much to do still. Okay, so we're going to talk about unit rates and then how we use unit rates mainly in science for converting measurements. And you do this so much in science, and it's a really big skill for chemistry too, I believe. So if you plan on going into any sciences, this is going to have to be where you're really focusing because it's so very useful. It's used all the time. Okay, so a rate is a ratio of two quantities with different units. So for example, 300 miles over 16 gallons. This is really 300 miles per 16 gallons. So my car traveled 300 miles for every 16 gallons of gas. Something like that. That would be a unit rate. A rate. Then we have a unit rate where we simplify the fraction. Instead of the 300 over 16, we simplify it so you get an actual number. So this bottom number needs to turn into 1. So I would actually divide 300 by 16. And when I divide 300 by 16, I actually get 18.75. And so then we go back to this miles per gallon. So when my car traveled 300 miles on that 16 gallons, I was averaging 18.75 miles per gallon. Remember that slash means per gallon. Because I took that bottom number and I changed it to 1. I changed it to 1 by actually dividing. So here, let's say we have a different vehicle that traveled 250 miles per 15 gallons. So we would divide that out. So 250 divided by 15 gives me 16.66666666. So my car or vehicle is averaging 16.666 miles per gallon. And again, this is an average because sometimes you stop, sometimes you go faster. When you go really fast, I think anything above about 60, your car starts using more gas. Anything below 45, your car starts using more gas. It becomes less efficient at those speeds. And so, again, this is just kind of averaging out how we go to kind of estimate how much gas we may have to use for a trip. So we have Rolf Lau, I guess. I don't know how to say that, actually. Of Germany, flipped a pancake 420 times in 120 seconds. So we have 420 flips in 120 seconds. To set the world record, find the unit rate. So I'm going to go ahead and take the 420 and divide by 120. And I get 3.5. What is 3.5? Well, this is where we go back to those units, and this is why it's important to pay attention to your units. This is flips per second. So for every 1 second, he flips it 3.5 times. I wonder how long it took him to get that good. Okay, so we use this whole idea of a unit rate to help us change units. And this is what we call dimensional analysis. So it uses rates to convert measurements from one unit to another. So we'd use something like 12 inches is 1 foot. And we'd help use it to change something that's in feet into inches or something that's in inches to feet. And depending on what we want to change, we would use either this fraction or this fraction. So we have to know the conversions between different units. So it's always a good idea to have it on hand. And if you don't have it on hand, then usually a teacher will give it to you or ask you to look it up, because since so many people have phones anymore, all it takes is a simple Google and you've got the answer. So to convert a rate from one set of units to another, we're going to multiply by the conversion factor, and we're going to let the units cancel. So if I'm trying to change from feet, I'm going to have feet on top. I need to have feet on bottom because like 2 over 2, here let me demonstrate this. So 2 over 2 cancels each other out. Or a 3x over 3x cancels each other out. 4 divided by 4 is 1. It cancels each other out. And so we do that to try and help change those units. So a sprinter runs 300 feet. So I have 300 feet, and I'm going to try and change that into miles. So I have my conversion. 1 mile is 580 feet. So I'm going to have my conversion factor, and I have to decide what goes on top, the miles or the feet. And because I want my units to cancel out, if I have feet on top right here, I need to have feet on bottom so those can cancel out. So that means 1 mile is on top and 5,280 feet is on bottom. And then what we're going to do is we're going to go ahead and multiply across the top and multiply across the bottom. So I multiply across the top, 300 times 1 is 300. The mile is still there. On the bottom, I have 5,280, no units. And so now I have a ratio. Now I can divide to find the unit rate. Whew. So we'll divide to find the unit rate. So 300 divided by 5,280 gives me 0.0568. And I'm going to draw dots to show that it keeps on going. Miles. And that's how I convert. And this is what we call dimensional analysis. And like I said, it's used all the time in science. So we're going to go ahead and try another one. And then we're done for section 1.8. So a cheetah can run at a rate of 60 miles per hour. So that means I have 1 hour on the bottom. Because when it says per hour, it means per 1 hour. In short bursts, what is the speed in feet per minute? So somehow I have to get rid of miles and turn it into feet, and get rid of hours and turn it into minutes. So let's start with hours and minutes because it's easier. So if I want to get rid of hours, hours is on the bottom, so I'm going to put an hour on top. Oops. Let's fix that. So hour on top. So 1 hour is the same thing as how many minutes? So I want to go from hours to minutes, so that's 60 minutes. Okay? So then I double check, hours will cancel out with hours, so now I have miles per minute. Then I want to change my miles now into feet. And we had that conversion before. We had miles up here. 1 mile is 5,280 feet. So if I want to get rid of miles here, I have to put miles on the bottom. So 1 mile is 5,280 feet. So the miles cancel out with miles, and now I multiply across the top and multiply across the bottom. So I would do 60 times 5,280, which is 316,800, and my units is feet. And on the bottom I multiply 1 times 60 times 1 is 60, and this is minutes. And then I find the unit rate. So then I divide by 60, and I get an answer of 5,280 feet per minute. Very, very fast. Of course, only short spurts, but still very, very fast. Okay, so that's it for chapter 1. After we're done with section 1.8, we're going to go ahead and have a practice test, which gives you the layout of the test, kind of lets you know what to practice. Are you ready for it? Do you know what you're doing? And all that, and gives you something to study from for the test.